Alright, so in this video, I have a simple question that I actually don't know the answer to. And that question is, can we average equations? And it just something that popped into my head, and I wanted to explore this in a video kind of live so you could see what the thought process might be like. So the only thing I've done in advance of the video is just draw a little graph so we can work with it. If you can't see it very well, let me show you here. So there's the graph, and it's got little grid lines. It's something that we should definitely learn to do with a straight edge and a pencil. Each space is just a 1/4 inch from the other space. That's how I drew that. So anyway, the idea in this video is to figure out, can we average equations, and what would that look like, and how would we do it? So I thought rather than starting this video with lines drawn, let's pick a point. Let's call it this point right here. So this point would be 3, 3, all right? And so let's draw 2 lines that pass through that point. We'll draw one that has a negative slope and one that has a positive slope. So let me just draw a line in. I actually want to make sure I'm drawing it correctly here. So we'll have the y-intercept here, and then we'll have a slope of -2/3. So down 1, down 2, over 1, 2, 3, down 1, down 2, over 1, 2, 3. So here's my first line. You know what? I'll draw it in red. So this is my first line here in red. I'm going to be careful that my pencil lead works. It's going to go right through those lines, or those points rather. So here's my first line. Okay? Maybe we can clean that up a little bit. Don't need all this extra line. There. And for the second line, we'll draw in blue. And in this line, let me create a different slope. This will be up 1 over 3. Okay, so I'll start here and go up 1 over 1, 2, 3, up 1 over 1, 2, 3. All right. So here's my second line. All right, so there's the second line. We'll create equations for these lines, and then we'll see what we have to do with those equations. Perhaps create tables. The idea here is, can I create an equation that kind of, when graphed, goes through here in this average distance between the 2 lines, passing through that point right there. So first, let's get our equation. So we'll start with the red line. I guess I could use the red pencil. We have a y-intercept at 1, 2, 3, 4, 5. Okay, so this is the red line. Has a y-intercept at 5. And it has a slope of -2/3. Okay, so if I just plug this into the slope-intercept form, I can write y equals -2/3 x plus 5. So that's my first line, and that's my red line. And my blue line has a y-intercept at 2, and its slope is positive 1 over 3. M equals 1 over 3. Okay, so how are we going to invent this average line? Well, one idea would be to average the slopes and then average the y-intercepts. I can see that being an idea. If we did that, we would have 5 plus 2 over 2. So this is our first idea down here. Idea 1. Average the slopes and average the y-intercepts. So the average y-intercepts, I have no idea if this will work. The average y-intercept would be 5 plus 2 over 2. 5 plus 2 over 2. All right, well, 5 plus 2 is 7, so 7 over 2. 2 goes into 7 3 times, with 1 as a remainder, so that would be 3.5. Let's see if that looks like it would be between these 2 points. So this is 2 and this is 5, and here would be 3, here would be 3.5. All right, so let me think what this would look like. So that's our little hypothetical y-intercept there at 3.5. And then what would be the average slope? Okay, so the average slope would just be the average of the m values. And we've got negative 2/3 and 1/3. So if I average the m values, I have negative 2/3 plus 1/3 over 2. Okay, well, negative 2/3 plus 1/3 is negative 1/3. See here, negative 1/3 divided by 2 is equal to, should be negative 1/3. So negative 1/3 divided by 2 is equal to negative 1/3 multiplied by the reciprocal of 2 over 1, which would be 1 over 2. Okay, so let's see what that is. You multiply the top, that's negative 1 times 1 is negative 1. And you multiply the bottom and you've got 6. So this is negative 1 over 6 would be my average slope. Again, no idea if this works. So our new line would be y equals negative 1/6 x plus 3.5. Okay, well, let's draw that in and see what it looks like. Okay, we don't even know if it'll be passing through that point right there, which is 3, 3. So we start at 3.5, and I'll go down 1 over 6. So down 1 over 1, 2, 3, 4, 5, 6. Okay, so it would be kind of like passing through those 2 points right there. And it does look like it would pass through the center point. So what I'm going to do is draw this in very lightly, kind of like this. Okay, do you see that line? Here, let me do this. See that line I drew in? It kind of does look like an average line, doesn't it? So let's see if that holds up if we try a second method. So idea 2 would be to create tables. This is our table idea. And then average the y values and the x values. Okay, so here's my table for my red equation. This is the red equation. Let's see here. I think we would have to have the same x values. Let's see how I want to do this. Yes, so if I have the same x values, so my x values will stay the same. We'll start with x is 0, and then when x is 1, 2, 3, and so on. So for my red values, what I'm looking at is the y value when x is 0. Okay, so when x is 0, y is 5. When x is 1, y is, well, we would need to plug that in, wouldn't we? We would need to solve that. You know what would be a lot easier is just to plug it in the calculator. Negative 2 over 3 x plus 5, and then hit second. Well, let me plug in the other equation. So the second equation, I guess I never wrote it. The second equation is y equals 1/3 x plus 2. Okay, so we'll plug that in. 1/3 x plus 2. All right, and now I'll hit second graph and look at the table. Okay, so let's be careful about how we pick our values, because you don't want to end up with these weird fractions. Okay, so this is my blue y values. So for my blue, when x is 0, y is 2. Right? I'm not sure I like these numbers. I guess we could use them. Let's see what happens later on in the equation. Okay. We will go ahead and use these numbers. So when x is 1, for my first equation, y is 13/3. 13/3. And my blue equation, it's 7/3. Okay, well, we should only really need 2 of these points, shouldn't we? So we only need 2 points to create a line, so that's enough right there. So now what we'll do is we'll have average. This is going to be the average y values, okay? So here is 5 plus 2 over 2, which we already did. 5 plus 2 over 2 is 7 over 2, or 3.5. Right here, 3.5. And then let's average 13/3 and 7/3. 13/3 plus 7/3 divided by 2. 10/3. And if I hit math, decimal, enter, I get 3 1/3, 3.3 repeating. Okay. Don't really like that value because it would be hard to plot. You know what would be interesting is to see if it will pass through at 3. When x is 3, we know that both of our equations have y values of 3. And so the average of 3 plus 3 divided by 2 is 3. Okay, so the average value would be 3. Okay. Let me find another value that would look good. Here, this 6, when x is 6, my red equation is 1, and my blue equation is 4, and so the average of those numbers, 1 plus 4 divided by 2, is 2.5. Okay, so what we'll do is we will ignore this ugly set of numbers here. We'll just chop that out. And we'll compute the change in x for these two and the change in y for these two and see what we get. So from 0 to 1, that's plus 1. From 3 to 6, that's plus 3. From 3.5 to 3, that's minus 0.5. And from 3 to 2.5, that's minus 0.5. Oh, I see what I've done wrong. So I'm going from 0 to 3 here. That's plus 2. Okay, and so now I'm going from 3.5 to 3. That's minus 0.5. And then from 3 to 6, that's plus 3. Okay, so this would be minus 0.5. We're not going to have the same change when we do it this way. Because here I'll have minus 0.5 over 2 and minus 0.5 over 3. It would not be constant. Oh, so from 0 to 3 is plus 3. Got it. Okay. So it is the same. So our change in y over change in x is equal to minus 0.5 over 3. And what does that equal? Well, let's see. So negative 0.5 divided by 3 is negative 0.16666666666. All right, so let's see, math, frac, that's negative 1/6. All right, so that would be my new slope. And my new y-intercept would be at 3.5, see? Because that would be the average of these two values. So I would have a slope of negative 1/6, and I'd have a y-intercept or a b value of 3.5. So look at that. By the table and by the averaging of those value of the slope and the y-intercepts, I get the same equation, negative 1/6x plus 3.5. So now I feel more comfortable going back here and graphing in. We'll do this with orange. Graphing in this line, which represents the average equation. What a great question to ask on an assignment. There's the average equation. Wow, I really like that. So let's compare these equations now, because I'll have this third one now. This is my, should probably get a pencil that's colored orange. Okay, so this is my orange equation. My y-int is 3.5, and my m is negative 1/6. So my equation is y equals negative 1/6 x plus 3.5. Now I wonder if it would work with parallel lines. I imagine it would work. I think this is really interesting. So the slope here is negative, even though one of the equations had a positive slope. Let's see if we can understand that. What is the magnitude of these slopes? So this magnitude of slope is bigger than this blue magnitude. So in the average, it would come out as a negative number since the negative slope was, in absolute value terms, larger than the positive slope. That is so cool. I love that. That's really neat. Well, I guess the answer to this question is yes. How cool. You know, I actually did not know that. And, you know, it's not something anyone ever taught me, but I think it's very interesting. I wonder how this could be applied in like a word problem. So imagine that you solved a system, okay, and then you wanted to find the average for some reason. What would be the average of two functions or something? I'll have to think about that because I imagine that you could really make this fun. And so like the homework assignment would be to write the equation of the average line and graph it on a coordinate plane. That is so neat. And you know, one of the really cool things is if we evaluate this function or this equation at 3, we should get 3. So if I go to y equals and I type in my new average equation, I'll have to type alpha y equals enter and put in negative 1/6 x plus 3.5. Okay, and then we'll just make sure that that graphs correctly. So in this the colors are flipped. I'll fix that. I can fix that. Look at that. That is so cool. Boom. Passes right through that center point. I love that. That is so neat. Wow. I really think that's cool. Okay, so if I go back to y equals, I can change this color to be red. And then I can change this color to be blue. There. And I can change this color to be orange right there. Now when I hit graph, it'll look just like what we drew. Look at this. This is so cool. I love this, man. This is so cool. I didn't know you could do this. You know, it's one of those things where nobody ever taught it. You know, nobody ever taught me. And so I didn't know it was possible. That is so neat. I absolutely love that. Wow. Look at the tables. And there's your table values. Wow, wow, wow. That is so cool. Anything interesting happening later on in the table? No? They just all diverge. Yeah. How cool is that? So that column there is the average values. That is so neat. I wonder if every single value is just the average of the two red and blue numbers. I bet it is. So you don't average the x values or anything like that. You just average the y values. And you average the slopes. That is so cool that you average the slopes like that. Wow. don't even know what to say. I wonder if it applies to quadratics. You would just average the y values from quadratic equations, and you would get some kind of average quadratic. Well, I'd have to check that out in a different video. But so cool. We can average equations. Yes. Wonder what Google has to say about this. Wonder if it's a thing. Let me just look real quick. Average equations. And we'll call it algebra. Average equations. The mean average, or simply, oh no, it's just telling me the mean average mean probability, blah, blah, blah. Let's see if we can create average two linear equations. Here. You can do it. Average the y values. Yeah. So cool. Mean line from several lines. I want to find the average line from different line segments. I don't know how to do this. That is so cool. Divide them by 2. So yeah, unanswered questions would be, what about vertical lines? Here are some unanswered questions. What about vertical and horizontal lines? Especially vertical lines. I think this question here is one. How would you, if one of your equations was vertical, it would not have a slope. So you could not average the slopes because the slope would be undefined. So how would you do that? You know, if one of the lines was vertical and then you had another one here and you'd want to draw some average line. Well, I have an idea. Let's just do it. So if we go down here, we can create this third column of data. And well, I guess we do it in green. Where's my green pen? Here's my green pen. So I would just want all of my points to be 3. Okay, so one of my equations would be just 3's. Okay, so this would be like 3, 3, 3, 3. But that's not true because where x is 0, it's not defined. Where x is 1, it's not defined. Only where x is 6, it's not defined. So it would only be valid here. So in what sense would you be averaging them? I don't understand now. Now I'm confused. So if the line is vertical, you know, if your equation is x equals 3, okay, and you have another equation, and that equation is, let's say, the red line, y equals negative 2/3 x plus 5. Y equals negative 2/3 x plus 5. How would you average those two? I guess all of your y values, think about it this way. You create a table. All right, so for the red equation, I have an idea. So for the red equation, here are my y values. 5, okay, and then 3. No, this doesn't work. I bet you, wonder if you do it the other way, okay? So I have an idea. What if we just take the x value? So when red y is 5, x is 0. So we'll just take the x values. So these are the x values of the red equation. Okay? And then here at 3, I've got 3. And then here I've got 6. Well, for my green equation, all of my x values would be 3, 3, 3. What is y when x is 3? I have an idea. So here's another idea. Scrap that, and let's do y values. So now let's ask, when y is 1, what is the x value of the red line? Okay, when y is 1, what is the x value of the red line? So we'll go backwards here. Let me go back to here. When y is 1, for my red equation, there it is, x is 6. When y is 1, x is 6 for my red equation. When y is 1, x is 6. Okay, I get it. All right. All right. Fair enough. We could probably do it visually. Look, when y is 1, my red equation has an x value of 6. When y is 2, what is my... Let's do this. Second window, change independent from auto to ask. So, ooh, it's not going to let me put in... Very interesting. Darn. I wonder if it'll let me change the dependent. All right. When y is 1, it's not going to let me do it. It never lets me do it. Just change them back both to auto. Okay. So when y is 3, x is 3. Okay. So when y is 1, x is 6. Okay. For my green, when y is 1, x is 3. All right. So now when y is 3, my x value is also 3 for my my red line, and my vertical line. Oh, I see the problem now is, okay, so my vertical line would also have this value. Okay, these are my x values. Okay. Well, so now what am I going to do? I need to compute change in y over change in x. So what am I doing? Do I average the x values now? Let's try it. Let's say 6, let's do this one, 6 plus 3 divided by 2 gives me 4.5. Okay, so this is my average x. This is 4.5. And then 3 plus 3 divided by 2 would just be 3. Okay, so I average the x values, and now we'll find the change here. So from 1 to 3, that's plus 2. And from 4.5 to 3, that's minus 1.5. Okay, so the change in y over the change in x equals 2 over negative 1.5. 2 divided by negative 1.5 is negative 1 1/3. Math frac gives us negative 4/3. So negative 4 over 3. Okay. And so now how would I find the y-intercept? Negative 4/3. I guess we could plot it. What if I go in here and plot this vertical line right here? And I'm looking for, which color am I going to use here? Let me plot this vertical line in brown. Okay, so there's that vertical line. So I'm trying to average it with the red line, so I want a line that's going to pass kind of this way. All right, let's see if it works. So I've got a slope of negative 4/3. So I'll start here at my one shared point and go down 4 over 3. So down 1, 2, 3, 4 over 1, 2, 3. All right, let's go back here and we'll go up 1, 2, 3, 4 over 1, 2, 3. Wow, are we about to do it? Let's see here. So we're going to connect these two. Is this the average between these two lines? You know, is this angle here the same as this angle here? It looks like this one's bigger, doesn't it? I don't know if that was the correct method. So in that example, I'm not sure. So what about vertical lines? I'll leave it there and just say, I don't know. Okay? I don't know. That would be interesting to know. If I look here on this stack exchange thing, you know what would be interesting is to set up an example where I have a 45-degree line here that would be like a negative 1 slope going through this point, 3, 0, and then have a positive 1 going through this point, and then I could average those slopes. So what is the average there? 1 plus -1, aha, is 0. Yes, and I can't divide that by 2. All right, it would be 0. I'm saying the slope is 0. No, the average slope being 0. Well, that would make sense because then 0 times x would be 0. But then you would have y equals. You would have a y equals. Yeah, I'm just not sure about that. So this green line is a total question mark. That is actually an interesting question. But we did find that we could average the other lines. I thought that was really cool. Okay, well, I will leave it there. And this is kind of how I learn things, you know. I don't, before I present them to you, I kind of work it out. And there's a lot of fumbling around and mess ups and kind of rambling thoughts. And I'm still curious about this, how to find the average equation if one of the lines is perfectly vertical. Okay, my guess down here is that we just list out the x values for that one equation, x equals 3, and then we list out the y values, or we list out the x values at different y values for our other equation, and then we create a slope after we average these two x values. So first I average the x values, then I find the slope, and once I establish that slope, I go to a known intersection point and start plotting in my slope, and then I find out that the y-intercept there would be 7. So the equation, here's the question, let me write this out. Would the green line have this equation? Y-int at 7 and a slope m equal to -4/3. Okay, so in this case, y equals -4/3 x plus 7. Okay, is this correct? Is that the average of x equals 3 and y equals -2/3 x plus 5? I don't know. I don't know, but I will leave it there. So I hope this was helpful and interesting. If you know the answer, please tell me, because I would love to show that to the students and have like a good explanation for why it works when you're dealing with the vertical lines. And if you think that this equation is correct, I'd love to know like why. Why is it correct? So let's leave it there. That was really interesting. I was just fascinated by that. All right, we'll see y'all later.